Good day, everyone. How are you today? I hope you are still enthusiastic to learn about my discussion. Welcome to my video discussion for today. In this video, you will learn about potential energy and kinetic energy. This is module 3 or MELC 3 of quarter 1, which is entitled Potential Energy and Kinetic Energy. Okay, let's start. But before that, the objective for today's discussion is to identify and explain the factors that affect the potential and kinetic energy. Before we'll start, let's know first what is the meaning of energy. Do you know what's the meaning of energy? Can you recall what you have learned in grade 7 or in elementary grades? Okay, correct. Energy is the capacity to do work. In grade 7, you learn about the different forms of energy, and you also learn the different ways by which energy can be transferred from one place to another. Okay, let us review first. What are the forms of energy? Energy can be a kinetic or potential. So when we say kinetic energy, this is the energy of movement. When we say potential energy, this is the stored energy. And there are examples of kinetic energy. In the right side, these are the example of potential energy. So first, we have the chemical energy. This is the energy stored in food, in fuel. Elastic energy, this is the energy stored in an object that are stretched. Like for example, the rubber band, the garter, and all rubbers. Another type of potential energy is the nuclear energy. This is the energy stored in the center of the particles. The center of the particles is what we call as the nucleus. That is why it's called as the nuclear energy. Another form of potential energy is the gravitational potential energy. This is the energy stored in an object when it is above the Earth's surface. Okay, let's have the kinetic energy. What are the examples of kinetic energy? Number 1, we have thermal energy or heat energy. This is the energy of moving particles due to the presence of heat. Mechanical energy, this is the energy of an object in motion. Electrical energy, this is the energy of particles moving through a wire. And magnetic energy, this is the energy caused by pulling or pushing using magnets. Okay, aside from kinetic energy and potential energy, there are also energy that acts in a form of wave. So one of these is sound energy, a form of energy that we can hear. This is due to the vibration of particles. Light energy is another form of energy that acts in a form of wave. Our eyes can detect. In grade 7 also, you learn about the different ways by which energy is transferred. One of these is conduction, convection, and radiation. Sound and light energy are transferred by waves. Electrical energy is transferred by moving particles or charges through a complete circuit. Heat is transferred either by random moving particles or by electromagnetic waves. So therefore, we can say that work also is a means of transferring energy from one object to another. Okay, take a look at this example, playing a bowling game. The child rolls the ball along the floor to hit an empty bottle. So this child has energy, and the energy from the child will now transfer to the ball, and then the energy in the ball will now transfer to the empty bottle. So question, is there work done on the ball? Describe this. Okay, at first this child apply force on the ball, and then once the ball hits this empty bottle, the empty bottle now will cover a distance. This bottle now will have a displacement. In order to know if there is work done, there are two requirements. First, there should be a force applied. Second, there should be a displacement. This is the distance from the origin to the next point where the object covers a distance. So in this case, there is work done on the ball. Why? Because there is force applied on the ball and the ball rolls. There is also work done in the empty bottle. Why there is work done in the empty bottle? It's because there is a force from the ball, and then after it was hit by the ball, the bottle covers a distance. So there is a displacement. So we can say that there is also work done on the empty bottle. So if there is work done, there is what we call as an object that gains energy, and the other object loses its energy. So question, which one gains energy and which one loses its energy? Okay, for this case, the child once do the work, the child loses its energy, and then the empty bottle gains the energy. So the work is done by the person on the ball. So when the ball starts moving, because of work done to the ball, it gains energy that enables it to move. So the energy now become what we call as the kinetic energy, or the energy of motion. And the person loses its kinetic energy. So what can a moving ball do? A moving ball has an energy. When it strikes the bottle, it can push a distance. Thus, work is done by the ball on the bottle. So the energy is now transferred to the ball. We can also say that work is a method of transferring energy. And the one doing the work loses its energy, and the object on which the work is done gains energy. This is why work is also a method of transferring energy. Okay, let's proceed. So, we will discuss only the two basic forms of energy, and these are potential energy and kinetic energy. Kinetic energy, or Ke, is defined as the energy of moving object. It is also called as the energy of motion. Kinetic came from the Greek word kinetikos, which means moving. The kinetic energy quantifies the amount of work the object can do because of its motion. So the equation for kinetic energy is Ke is equal to 1/2 mv squared, where m stands for mass and v stands for velocity. The unit of mass is in kilogram. The unit of v is meter per second squared. Take note that it is squared. So the velocity is squared. So this means that you multiply the amount of velocity by itself, not you multiply it times 2. Question: what is the unit of kinetic energy? Okay, to get the unit of kinetic energy, we have to use or derive the unit of mass and velocity. So, if the unit of mass is in kilogram, and then the unit of velocity is meter per second, and then squared, this becomes kilogram meter squared per second squared. So from our previous lesson, we all know that kilogram meter per second squared is equivalent to 1 Newton or Newton. So what happened now to the other m? So this becomes Newton meter or J or joules. This is the unit of kinetic energy. Joules, Newton meter or J. So let's recall our objective. Identify the factors that affects the kinetic energy. So the answer for this is kinetic energy of an object depends on its mass and velocity. So actually the answer for the objective are mass and velocity. These are the two factors that affect the amount of kinetic energy. Okay, so let us solve problem number 1. Problem number 1 states that a 1,000 kilogram car has a velocity of 5 meter per second. What is its kinetic energy? Okay, the solution is first identify the given, second write the equation, third substitute the value and then solve for that. Okay, first, so the equation for kinetic energy is 1/2 mv squared. Substitute the value of mass. So 0.5 times 1,000 kilogram times the velocity 5 meter per second and then squared. So all you have to do is multiply 5 times 5 times 1,000 times 0.5. And the answer is 12,500 joules or 12,500 J. Or you can also solve in this way. 1 over 2. So 1 times 1,000, that's the mass, times 5 times 5, that is 25, divide by 2. Still the same answer, 12,500 J. Okay, what if we're going to double the mass? So this is the problem. A 2,000 kilogram car has a velocity of 5 meter per second. What is its kinetic energy? So the solution is find the given. So one given is 2,000 kilogram, that's the m. Second given is 5 meter per second, that's the velocity. And then write the equation for Ke, that is 1/2 mv squared. Substitute the value of mass. So 0.5, that is 1/2. The mass is 2,000. The V is 5 meter per second and then squared. So you multiply 5 times 5 times 2,000 times 0.5 and the answer is 25,000 J or joules or Newton meter. So if the mass is doubled, this is the result. So take note that if the mass is only 1,000 kilograms, its kinetic energy is 12,500 J. But if we're going to double the mass, which becomes mass is equal to 2,000 kilogram, the kinetic energy now becomes 25,000 J. So if the mass is doubled, its kinetic energy also is doubled. Okay, so what will happen to the kinetic energy if the velocity is doubled? Okay, let's try this. So let's say we'll double the velocity from 5 meter per second to 10 meter per second. So the solution is this one. So this is the solution. 1/2 is 0.5 times 1,000 kilogram, that's the mass. And then the velocity now is 10 meter per second. So this is how to solve. 10 times 10 times 1,000 times 0.5. And the answer for kinetic energy is 50,000 joules or J. Okay, so let's compare. So if the mass is 1,000 kilogram and the velocity is 5 meter per second, the kinetic energy is 12,500 J. But if we double the velocity, the mass now is 1,000 kilogram and then this velocity becomes 10 meter per second. That's from 5 meter per second, we make it 10 meter per second. So the amount of kinetic energy if the velocity is 10 meter per second, it's 50,000 J. So what happened is this 12,500 becomes 4 times. So when we multiply 12,500 times 4, that is equivalent to 50,000 J. So if the velocity is doubled, we can say that the kinetic energy is 4 times or quadruple. That is 12,500 times 4 is equal to 50,000. So we have to remember that if the mass is doubled, the kinetic energy is doubled. If the velocity is doubled, its kinetic energy is quadrupled. So the kinetic energy now is directly proportional to the mass and velocity. Meaning, if the mass is increased, its kinetic energy also increases. If the mass is decreased, the kinetic energy also decreased. Same thing with the velocity. If the velocity is increased, the kinetic energy will increase. And if the velocity is decreased, the kinetic energy will also decrease. So they are directly proportional. Okay, problem number 2. What is the kinetic energy of a jogger with a mass of 65 kg traveling at a speed of 3 meter per second? The solution is the kinetic energy is equal to 1/2 mv squared. So 0.5 times 65 kilograms times 3 meter per second and then squared. So 3 times 3 times 65 times 0.5 and the answer is 292.5 J or joules. Okay, let's proceed to the potential energy. Potential energy is a stored energy. When you lift an object, the object gains energy. So since the work is done against the force of gravity, it is called as gravitational potential energy or GPE or PEgrav. So to calculate the potential energy, we're going to use this equation. So PGE or potential energy grav is equal to mass times G, gravity times H, that is height. Mass times gravity times height. Okay, so what is now the unit of potential energy? We derive it from the formula or equation. So potential energy is equal to mass times gravity times height. Always remember that M stands for mass, G stands for gravity, and this gravity, take note, is constant. That is 9.8 meter per second squared. H stands for height, and that is in meter. So how to find the unit for PE, or potential energy? So substitute the value of mass, that is in kilogram, then grams. The G is for meter per second squared, and H is for M. So combine kilogram meter per second squared, that is 1 Newton. Copy this remaining M, so it becomes Newton meter, or J, or joules. This is the unit of potential energy. Okay, let's solve this problem. A ball with a mass of 10 kilograms is lifted from the floor to a table with a height of 0.50 meter. What is the potential energy of the ball after it was transferred to the table? Okay, solution. So the given are 10 kilograms, that's the mass, and 0.50 meter, that's the height. Write the equation. The equation for potential energy is mgh. So substitute the value of mass 10 kilogram, the value of gravity is 9.8 meter per second squared, and the value of height is 0.50 meter. You multiply 10 kilograms times 9.8 meter per second squared times 0.50 meter. The answer is 49 J, or joules. And if we're going to increase the height, what do you think will happen to the potential energy if we double the height? So the mass is still the same, 10 kilograms, and then the gravity is 9.8 meter per second squared, and this height becomes 1 meter. From 0.5, it becomes 1 meter. So you multiply 10 times 9.8 times 1, the answer is 98. So what do you observe with the amount of potential energy as the height is increased? So from 49, the potential energy is 49 if the height is only 50 meters. Then it becomes 98J if the height is 1 meter. So it will increase. So if the height is increased, the potential energy also will increase. Okay, what if the height is in zero? What do you think is the amount of potential energy? So the equation for potential energy is mgh. So the mass is 10 kilograms, the gravity is 9.8 meter per second squared, and the height is 0. You multiply 10 times 9.8 times 0, the answer is 0. So therefore, we can say that if the height of an object is 0, the potential energy is 0. Take a look at this example. If we're going to have a bicycle going up to the top of the hill and then down, what do you think will happen to our potential energy in every point? Okay, let us see point A. Half of this. Okay, so when this bike climbs up, the potential energy will increase. So once it reaches the top of the hill, it has the highest height. So meaning this time, there is what we call as the highest potential energy at the highest height. So when it goes down, the potential energy will decrease. It's because the height is also decreasing. So if the factor that affect the potential energy actually, class, is the height. If the height is increasing, the potential energy also will increase. So if the height is decreasing, like going down, so the height will decrease. Same with the potential energy, it will also decrease. But this is opposite with the kinetic energy. So when this bike goes up, what happened to the kinetic energy? it will decrease. Why? Because the factor that affect the kinetic energy is the speed or velocity. This bike goes up, meaning the speed will decrease, so the kinetic energy will decrease. So when the bike goes down, the kinetic energy will increase. It's because the speed will increase. So the two factors that affect the kinetic energy are mass and velocity. And the factor that affect the potential energy is the height. Okay, to summarize everything, we have to remember these concepts. The energy can be kinetic or potential. The kinetic energy is the energy of moving. Kinetic energy is dependent on the velocity and the mass. So if the mass is doubled, its kinetic energy is doubled. But if the velocity is doubled, its kinetic energy is 4 times or quadruple. And the potential energy is a stored energy. It is dependent on the amount of height of an object. Okay, this time, you're going to solve this one as your assignment. Okay, write this one in one whole sheet of paper and then submit this one during the time of the retrieval of module. Okay, problem solving number 1. A 50 kilograms object is lifted 5.5 meters above the ground level. Find its potential energy. Okay, number 2. A 12 kilograms cat who is rested on a tree has a potential energy of 50 J. Calculate its position or height relative to the ground. And last number, a 50 kilograms object moved at the velocity of 6.3 meter per second. Find its kinetic energy. That's the end of my discussion. Thank you very much for listening. I hope you learned a lot from my discussion. This is Ma'am Debbie saying thank you and God bless you everyone.